This entire thing is our finished electrical system, and we're going to show you how we got here and how you can also get here. This week's episode is all about our camper electrical system, which in terms of time consumption is probably the biggest thing that you have to research. And in hindsight, we probably would advise you to not do this yourself if it's your first camper. There are a lot of professional companies who will either do partial electrical or full electrical builds for your camper van, so you can concentrate on all of the rest and don't have to do this particular part yourselves. If, however, you want to do it yourselves, well, props to you, and we'll give you a simplified explanation of how we ended up with these parts, how we're going to use them, and especially where you can get all the information that you will need for your own electrical build.
The first step in every custom electrical setup is figuring out your personal electrical needs and how you're going to support them. The easiest way of figuring this out is to use one of the many electrical calculators that you can find online, like this one that we used, which is from Far Out Ride. Here you have to put in all the electrical devices, how much amperage they draw, and an estimate of how much you are going to be using them. You are then presented with some data that might not make much sense to you now, but this will be the basis of how you build your electrical system. Going forward, you have two options that we would recommend. The easier of the two is using one of the complete guides that you can find on the Explorers website, which we will link down below, considering that you fall into one of these categories. There you can find a list of all of the things that you will need and an overview of how to connect them. The more difficult but possibly cheaper option is to search, choose, and figure out how to connect the components yourself, which is what we did. For this, the two most important values you are given by the Far Out Ride calculator are the ones for the battery bank size and the solar panel wattage.
So starting with the battery bank, you're given the amp hours that you will need, and through those you can find out what kind of battery bank size you will be getting. There's a few different options in terms of battery types, but in the end it will probably boil down to either lithium batteries or AGMs. A complete breakdown on what battery types are, what to choose, and why to choose them, you'll be finding right here. We ended up buying 4 100 amp hour Renogy lithium batteries, which makes up a 400 amp hour battery bank. Even though 300 amp hours was recommended, we just wanted to future-proof and found a very good deal. So there are multiple ways to charge your battery bank. For most people building an off-grid camper van, the most used and most important source is going to be solar. The Far Out Ride calculator gives you an approximate wattage that your solar panels should have, and based on that you can then choose from the vast variety of solar panels on the market. If you need multiple solar panels to reach your wattage, you will then have to decide to either put them in series or parallel. There is a very good guide linked up there. Once you've done these two steps, it's time to choose your solar charger. This device converts the voltage and amperage from your solar panels into usable amperage to charge your batteries. Using the exact data of your solar panels that you can usually find in the product data sheet and the information you have acquired on how many panels you have and how they are wired, you can figure out which solar charger you need through this calculator by the Explorers.
Another way of charging your batteries is to use an alternator charger. As the name states, it uses the already existing alternator of your car and tops up your batteries while you're driving. In order to figure out which alternator charger is right for you, we recommend reading two blog posts, one by the Explorist and one by Climbing Van, which we will link down below. There is a third method of charging your batteries, which we will cover later on when talking about a 230 volt AC system. At the heart of your system lies a positive and a negative bus bar. A bus bar is where all your components' cables come together, are properly fused, and are connected to your batteries. Normally you will have a positive bus bar with fuse holders attached to it and a separate negative bus bar for all of your grounds. If you're on a strict budget and you want to have a highly customizable bus bar, then this is a guide by the Explorers on how to make your own. The other more expensive but much more convenient option is to buy a pre-manufactured bus bar or even a combined package bus bar like the Lynx Power In that we are using. This then contains a negative bus bar, a positive bus bar, and fuse holders. The last component of your 12-volt system will be one or more DC distributors, depending on how many devices need to be powered in your van. This is basically a mini bus bar where each device gets connected with its positive and negative wire, has its own fuse holder, and is therefore safely connected to your 12-volt system.
There's also the option of having an AC system that you would normally have in your house running off of your 12-volt battery bank. For this to work, you will need an inverter. The inverter transforms 12-volt DC to either 120 volts AC or 240 volt AC if you're in Europe. To choose the inverter, you need to figure out the highest wattage device that you want to run off of the AC and then size your inverter according to that. Each inverter size also has a minimum requirement of power bank size that you will have to run the inverter, so watch out for that. But for an in-depth guide on how to choose your inverter, you should probably go to this and watch this entirely. With the option of an inverter also comes the option of a third charging method. An inverter charger combo gives you the option to install a shore power plug like our CEE plug on the outside of the van and then charge your battery bank from shore power when you're connected to the normal AC grid. It also gives you the option of powering all of your AC devices without using battery cycles, as you will just putting through 230 or 120 volts to your devices. For safety reasons, you should also install a fuse box between your shore power plug and the inverter. Obviously, for the entire system to work, you also need cables. Cables connect all the components and run to each and every device you have in your system. Unfortunately, choosing the correct size of cables sounds easier than it is and is way more important than it seems. Cable sizes are mainly dependent on the amperage you want to put through them and the length of the cable itself. You most probably won't run adequate cable sizes for every component because it's usually cheaper to buy cables in bulk, which makes it more realistic to figure out a couple of sizes that you will need in your entire van build and then buy those in long length. Remember that with cables you can always size up as there is no minimum amperage that needs to be running through, but never size down as there is a serious fire hazard. Run. We therefore have 4 different cable sizes: 1.5mm, 4mm, 60mm, and 70mm, which are our thick battery cables. These worked well for us, but can obviously be completely different for what you need. So we recommend using this wire size calculator by the Explorers that we will link down below.
One last thing needed in your electrical system is your fuses. You've probably heard that fuses are used in order to protect the device attached to the cable. This, however, is a big misconception. The devices usually have their own fuses integrated into them and they therefore need no further protection. It is, however, very important to have a fuse in every cable that you run in order to prevent the cable itself from overheating and burning through. In most cases, finding the correct fuse size is pretty straightforward. Sometimes you can even find the recommended fuse size in the user's manual of the device. Otherwise, you just need to do a quick calculation. First, find out the maximum amperage draw of the device that is connected to the cable. This can oftentimes be found in the product information, or if you can only find the wattage of the device, you divide the wattage by the voltage and find out your amperage. Then you take that number times 1.2, as it is recommended to have a fuse rated at 120% of the amperage that you draw. This is so that you have a bit of a buffer so it doesn't blow out your fuse instantly if you have a surge change in current, but it is low enough so it burns through before your cable. Lastly, double check that the amperage of the fuse doesn't exceed 150% of the maximum amperage of your cable. Otherwise, you should be using a bigger cable. Oftentimes, you won't find the 100% correct fuse that you are needing. In that case, just size up to the nearest fuse, but make sure that it stays under the 150% amperage of the cable. I personally found it easier to calculate the fuses myself, but you can also use or double check with the fuse calculator by the Explorers, which we will also link down below. If you have any further questions concerning our electrical system or any of the components we used or fuse sizes that we used or cable sizes that we used, anything at all, feel free to contact us either in the comments down below or also you can send us a message on Instagram.
Okay, now that we got all of our parts, we need to find a way to fit all of those things inside of this little box. I've done some pre-testing back in December last year with approximate measurements as we had our design basically fixed, but now it's on to getting it completely done and we're gonna figure it out. I don't know. We're definitely gonna put the batteries in parallel in our bottom compartment, and then we already decided that we're gonna put one piece of wood right here where all of our other parts are gonna sit. We're gonna put both our charge controller and our solar charge controller horizontally. Although the manual states that they should be mounted vertically, we don't really have a lot of room here, so we're gonna mount them horizontally but put fans right in front of them, so there will be adequate airflow to hopefully cool down all of our components. The other one will sit right there.
Busbar.
Okay. Busbar goes right in the middle as our leads barely make it there. Our leads barely make it there. Then we have two 12-volt DC distributors. These are gonna go on the wall where we're supposed to put the charge controllers. These are gonna go right here. Then our two 30-volt fuses are gonna sit right here. And then the chunker, the chunky boy inverter will sit right in the front as there's enough room around it so it won't get too hot and it will have adequate airflow as this has its own fans. We decided to make two wooden stands that are going to go under here to give the batteries a little more clearance so we don't smush any cables or any connectors, then to be able to attach the inverter to those so it's also securely screwed down.
And we also have two slats of wood that are going to kind of enclose the batteries so that they can't move around and are just tight in there where they're supposed to be.
Okay. So one of the bigger problems that we've encountered is that our batteries have their own on and off switches. The energy batteries that we're using can be turned into shelf mode, where it's a very low voltage, so they don't drain basically at all. If you're not using your van for a long time, you put them all in shelf mode and they will not drain basically. Normally people put a cutoff switch, like this chunky boy, between their batteries and their bus bar, so in an emergency you can just flip the switch and turn it off. Since our batteries have power switch integrated, we're just going to use those, but the problem is there's connectors on all four of them and you have to press them manually, so we have to drill tiny holes into this one and then have the connectors plugged into the batteries and then just be able to turn them into shelf mode. Does that make sense?
I guess.
We're sticking with it. Okay, so scrap whatever we just said, because while technically you're supposed to put these energy batteries in shelf mode whenever you're leaving them for a longer time, the thing that we found out is that when you put them in parallel, you're supposed to disconnect all of them before putting them back into shelf mode, which is not possible with our current configuration. So the new plan is put one little wooden stick right here, put the plate that we made on top of it on hinges.
Hinges.
This is just so it has something to rest on while so the hinges don't have to take all of the force because the components on top are quite heavy. And then make this, well, movable, so we can work on the batteries if we have to, and also disconnect them and put them into shelf mode if we leave the van for a longer time. Since we made quite a few changes, we're just gonna see if we can repackage everything, as our original plan was not working. So now that we've decided on another design for our electrical system, I'm gonna drill 3 holes next to these 12-volt distributors so we can feed the cables through the back and then just stack them neatly. Holes are made and routed and well smooth, so no cables will rub open on them. It's time to install these 2 distributors this way around, and then we'll go from there. Now it's time to put the entire L couch into the van and finally bolt it down so we can move on to actually putting the electrical in there. So since the entire electrical system needs to be grounded to chassis, we're gonna make a hole big enough for the M8 bolts that I'm gonna use to ground the entire thing. It is important that you scratch any remaining paint off of the connection so that the electricity can flow easily into the chassis.
So now that we have our finished system, I'm going to give you a quick rundown of where we put everything and how all of this is generally connected. So on the bottom compartment, we have our battery bank, so our source of power. We have our 4 batteries put in parallel next to each other, and we can access these by lifting up this piece of wood. Then the only thing that they are connected to is the bus bar, which is right here. On our bus bar, we have on the bottom compartment each of our negatives. On the top compartment, we have our positive leads, and then have the positives connected to a fuse. This connects our whole system. On the top here, we have all of our 12-volt components. So we have the alternator charger that is connected to the bus bar and to the alternator in the front. Then we have our solar charger, which is obviously connected to the solar and also to the bus bar. And then we have our 2 DC distributors. These are all of the devices that we're going to be using in the van. We have some slots left right here for if we want to put anything else in afterwards. There aren't that many, so let's just hope that we should be fine with this. And for our 230 volt AC system, we have the inverter sitting in the front and have our fuse block sitting right here in the back. That's our whole system stored away nicely into our couch, so when we close this up and put in our front, you won't be able to see any of this, and we can easily access it from here. One thing we unexpectedly had a lot of problems with is these cable lugs. So we ordered cable lugs for the different sizes of cables that we had, and for some reason for the 16mm squared cables, none of them fit. So we started out with some that looked like this, then we had some that looked like these but a lot thinner, and all of them just came off. Doesn't matter which crimping tool you used, or we even ordered a different cable to see if the cable was the right size. Nothing seemed to work. And then we asked a friend of mine who's an electrician, and he got us these, which are a lot more stable, a lot thicker, and actually worked. So just something to be aware of, that if things don't work out the first, the 4th, or the 7th time, it's not necessarily your fault. It could just be bad manufacturing or something else. So if you want to be sure, try to ask an electrician or someone who knows their way around this, and get yourself some good cable lugs. One more thing that we did that we have not necessarily seen done this way before is that we used these 2 bolts of the bus bar. These are usually so that you can connect multiple bus bars together easily, and since it is just part of the positive and the negative bar, we just use them to attach our components to. We did try to make it as safe as possible, so we also put a fuse into here, and we obviously have everything sealed off nicely, so we just hope that this is fine and not a safety hazard. So this was definitely probably the most difficult part of our van build, and we're very happy that we are finished with this. If you have any other questions, or if you feel like we did anything wrong, please let us know, and otherwise we will see you next week.
If this will turn on again, I will also tell you the rest. I've done some pee.
Where's the poop, Robin?
No.
Then the first thing that they go to...
The goat.
Then the first
Nicholas
thing...
Latifi.